Hi guys, welcome back to my channel. So in this video we're solving this question where we have this one as find the work done by the force, and we're given the force as a function, as a vector function traveling along the curve C, which is given to us. And so every time we need to find the work done between two curves, we always use the Green's theorems for that. Okay, and I've already made a lot of videos on Green's theorem, so if you guys want to check those out, you can check it out in the playlist. Okay, so let's get started with this question. So since we're using Green's theorem, I hope you guys remember from previous videos, the formula for Green's theorem is basically qx minus py, and the integral, the double integral, and dA. Okay, so in case you don't remember or like forget an exam, so there's a trick to remember this. So remember always the p component is always associated with the x component, okay, and the q is associated with the y. Okay, so you simply have to do like inverse determinant, because in determinant you go like top to bottom, right? So you always have to go like in the inverse direction, so like bottom to top and then negative top to bottom. So here you go, if you do this, so you get like qx. Okay, so you get like qx and then you do from top to bottom then negative py. Okay, it is as simple as this. Okay, so once we have the equation for the Green's theorem, we simply have to plug the things in, okay, and solve it. Okay, so qx, what does that mean? So qx means the partial derivative of q with respect to x, and py means partial derivative of p with respect to y. Okay, and like I just said, the q corresponds to the x, the p corresponds to the x component, right? So the I hat, so this is the, let me change colors, so this is p, okay, and this one is q, okay, because it's associated with the j component. Okay, so we have over p and q over here. So now it's simply to plug it into the formula to find it. Okay, so first we need to find q of x, means partial derivative of the function q with respect to x, and with respect to x means y is a constant. Okay, so y is a constant, so they're gonna stay over there, and we're only differentiating 2. Okay, so the derivative of x is 2x. Okay, and then negative py, so the derivative of the partial derivative of p with respect to y, which means this time x is a constant and we're only differentiating y. Okay, so now we have dA. Okay, now dA means we need to put it in the form of like dx, dy, or dy dx, depending on which direction we choose to go here in the region, right? And it's gonna change depending on this. If it's y dy, that means we're gonna set these limits to y, and if it's starting with dx, that means it's gonna start with x. But here you guys see this is a circular region, and every time you have circles involved, please don't use dx dy. You're gonna end up complicating your life for nothing. Okay, so every time you have circles involved, what do we guys use? We always go for polar coordinates, remember? Okay, so every time you have any question in exam which involves circles, please go for polar coordinates. It's gonna make your life so much easier. Okay, so because if you choose to go like dx dy, you're gonna have to solve for x, and then you will have like square root something, and it's gonna be ugly to you know to integrate the x, the square root, because you will have to do like u substitution and all, and it's hard. Okay, so let me choose the easier way, which is polar coordinates. So for polar coordinates, remember, every time we're gonna have x, we're gonna replace it by r cosine theta. Okay, and every time we see a y, we're gonna replace it by r sine theta. Okay, and the dA that I had over here, why did I remove it? Okay, so yeah, dA. So we have a dA over here, and we're gonna replace the dA with r dr d theta. Okay, so this is very important to remember for the polar coordinate. Just remember this, and it's a piece of cake for you. Okay, and yeah, don't forget this r. Okay, this r is very important. I remember myself, like I forgot to write it in the midterm, and I got like I didn't get the correct answer because I forgot this r. So make sure to remember this r very well. Okay, so because people tend to forget it, including me. Okay. Alright, so before we move on and put these equations into this one, what we have to do first is we need to do some algebraic manipulation so that it looks cleaner. And before I do that, I just recall I made a mistake over here because it says qx minus py. Okay, so there was already a minus in the equation which I wrote over here, but here there is a minus over here as well, so that's gonna be like 2y. Okay, so that's gonna be negative 2y. Okay, and negative it's gonna make it positive. Okay, so it has to be positive 2xy. So now it's 2xy and 2yx, it's the same thing, so 4yx at the end. Okay, so now we can finally go ahead and replace this 4yx with these coordinates. So now y is going to be replaced with r sine theta and x is going to be replaced with r cosine theta. Okay, and this dA, remember this is very important to multiply with the r, right? And then dr d theta. Okay, so now that we have this, now because we're integrating with dr first, so these has to be r equals to something and d theta at the end, so this is gonna be theta and theta. So now let's find the limits of this one, so the limits of integration. Okay, so for this you need to look at the region, and okay, so this is our region, right? This inside thing that you see over here, and it's starting from this circle and going to this circle. Okay, so the lower limit for the r, it's gonna be r equals to 1 because the radius of this circle is 1, right? The equation of the circle is given and the radius it says 1, so the lower limit is r equals to 1 and the upper limit is r equals to 2. Why? Because the radius of the circle is r equals to 2, because the equation of the circle is r squared plus y squared equals to x squared plus y squared equals to r squared. Okay, and since it's r squared, so that's why the radius is 2 and not 4. Okay, so now we have our radius, we have 0 to 2, and now for the theta we simply look at the angle. So if you look at the angle, it's going from this to this. Okay, so we're starting at 0 and we're going to 90 degrees, and 90 degrees in radians is pi over 2. So we're going from 0 to pi over 2. Okay, 0 to pi over 2. Now that we have set up our integral, the rest is pretty easy to do, right? So we're going to multiply this r with this function, so we are left with 4r cubed sine theta cosine theta. Okay, and then we have dr d theta, and again the limits stays the same. Okay, now once we have this, you can break this integral basically into two parts because it has dr and d theta. So what you can do is split it into two parts and then multiply the results. Okay, so here we have theta equals to 0 to theta equals to pi over 2. Okay, and here we are only going to write the theta equation, so sine theta cosine theta d theta. Okay, and here we can split only the r part, which is 4r cubed dr, and we have r equals to 0 to r equals to 2. So we have split this integral into two parts. Okay, so if you don't want to do that, it's totally fine. Just to make your life a little easier, you can go ahead and split it into r and d theta and solve for this one, and multiply these two together. Okay, or like solve this one and multiply with this one and then solve it, and you're gonna get the answer. Okay, or what you can do is like you can solve it all together, like but it's basically the same thing because you're solving this one inside this, but you keep everything together. Okay, so let's do it this way, the splitting way. So this one looks easier, so let's solve this one first. Okay, so we have dr, we're integrating with r. Okay, so we're gonna put r4 over 4, and then we have from r equals to 0 to r equals to 2, and this is going to cancel out. This 4 cancels out, and we're going to plug it inside. So we have 2 to the power of 4 minus Oh wait, I guess I made a mistake. This has to be r equals to 1, the radius. Okay, so remember the radius for this circle, it was r equals to 1. Why did I write 0? Sorry for that. So yeah, it has to be 1. So 1, and yeah, 1 over here. Okay, so it's gonna be 1 to the power 4, which is basically 1. It doesn't matter. Okay, so it should give you 15 over here. Okay, so now you got the answer for this one. So you can simply go ahead and multiply this 15. Okay, so let's go ahead and multiply this with 15. Okay, so we have then 15 sine theta cosine theta, and integrals from 0 to pi over 2, and we have d theta. Alright, so now to solve this one, you need to know a trig identity. Okay, so the trig identity is as follows. So you have like sine 2 theta, so yeah, sine 2 theta is equals to sine theta cosine theta, but with the 2 over here. Okay, so this is the identity, but we do not have a 2 over here. So what we'll do, we'll simply like divide this trig identity by 2 both sides. Okay, so now it's gonna have 2 over here and not here. Okay, so now it becomes how we want it. So this thing, we replace it with this trig identity. Okay, so now this is gonna be replaced, and you need to unfortunately memorize this trig identity because it won't be given in the final, because I remember we didn't have this given. Okay, so sine 2 theta over 2, okay, pi over 2 d theta. So now we can finally integrate it, and when we go ahead and finally integrate it, so you remember how we take the derivative. So sine x, the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. And when we're taking the integrals basically mean undoing the derivative. Okay, so we have sine already. Okay, so we're undoing it, which means we're when we undo, we get cosine x. Okay, but with a negative. Okay, so we're gonna get okay, so we get cosine x. Okay, so oops, sorry, cosine 2 theta, and then what are we going to do is no, I forgot this 15. Okay, so 15 over 2, that's gonna stay over there. Okay, and when we take the integral, okay, remember that it has an inside function as well, and since it has an inside function, we're gonna divide it by the derivative of the inside function. So the derivative of the inside function is 2 theta. So the derivative of 2 theta, like for example 2x is 2, right? So the derivative of 2 theta is simply 2. So we're gonna write it over here, and then we can go ahead and substitute our zeros and pi over 2 here inside the equation. And yeah, I forgot the 15 over 2 over here, but we had. Okay, so then it's gonna become 15 over 4 because we're multiplying with the 2. So 15 over 4 negative cosine 2 theta. So then it's gonna become like negative 15 over 4 cosine 2 theta, and theta is gonna be replaced with pi over 2. So pi over 2 negative cosine of 0. Okay, and if you solve this, you should get a fraction, and that is gonna be your final answer. And let me know in the comments below what you guess as a final answer, and thanks for watching. Bye.